All right, let's go ahead and get started with Chapter 12. Now we're going to be talking about forces. And the first force that we're going to talk about is weight. And let's discuss the difference between weight and mass, because they are not the same. You've got to make sure you know that they are not equal to one another. Now, mass is the measure of how much matter is in an object, and weight is the gravitational force an object has due to its mass. And so make sure that you realize those differences. Now, weight of an object depends on location. So a change in an object's location will change an object's weight. Now, as you can see, weight is the gravitational force an object has due to its mass. So basically, weight is how much force is being put on the earth because of how much mass I have, okay? So my weight is telling me and everybody else how much force I'm putting on the earth. And the reason is because the gravitational pull is pulling me to the earth, and then my mass is causing a force on the earth, and then we call that weight. Now, if you look at the bottom, I believe it's page 1, and you have a chart called acceleration due to gravity. And that shows you the gravitational pull on each planet, or not on each planet, I'm sorry, on some of the planets. And that's why weight changes, because on different planets you have a different gravitational pull. Now, if we're calculating weight, we're going to say mass. So if I was calculating my weight, I would say my mass times free fall acceleration. Free fall acceleration is just gravity, the gravitational pull. So I would say my mass times the gravitational pull of whichever planet I'm on, which obviously we're on Earth, right? But we can calculate people's weight if they were on a different planet. So weight is represented by W in the formula, mass by M, and free fall acceleration is represented by G because it is gravitational pull. Now, weight is measured in newtons, and I'll show you how they get newtons in just a second when we get to our practice. So let's go ahead and move to our practice. We're going to practice number 1 all together, and then 2 and 3 you're going to do on your own, but resume the tape to see the solutions. All right, we've already got our W equals M times G. Now, let's go over and make our circle. And the M and G are next to each other in the formula, so that means they have to be next to each other in the circle. So we have M, G, and then W. All right, now let's go ahead and do number 1. How much would a person weigh on Earth if their mass was 150 kilograms? Now, I'm going to go ahead and tell you, we talked about Newton being the SI unit for weight and force. And if you look, mass is going to be in kilograms when we're dealing with weight and force. And the gravitational pull is always in acceleration SI unit. And so instead of having to write this every time as the units for weight or force, that's how they came up with 1 Newton. Okay? So whenever you're dealing with weight or force and calculating it, if you ever have to find mass, the mass is going to have been in kilograms. Now, how much would a person weigh on Earth if their mass was 150 kilograms? So we write our variables first to see what we know and what we don't know. So how much would a person weigh? That means the weight is a question mark. Their mass is 150 kilograms. And remember, G is always either given to us in a problem or we look on a chart that's provided for us. The gravitational pull on Earth is 9.8 meters per second squared, and I've got our chart up top so that we can look at that and see that. Now, let's write our formula in letters. W equals M times G. Then we fill it in with numbers. W equals 150 kilograms times 9.8 meters per second squared. And once you calculate that, you're going to see that you get W equals 1,470 newtons. So this is the weight of that person on Earth. All right, go ahead and pause the video and resume the video once you're ready to look at the answers. All right, let's go ahead and look at this problem. We have W equals, M equals, G equals. And it's the same person in number 1. They ask us how much would they weigh, so that's the question mark. It's 150 kilograms because it's the same mass. and Pluto's gravitational pull is 3.9 meters per second squared. Now, W equals m times g, and so if we fill in our formula with numbers, we've got 150 kilograms times 3.9 meters per second squared. And if you put that in your calculator, you're going to say 150 times 3.9, and that equals 585 newtons. So it looks like if I lived on Pluto, I'd weigh less. So maybe I should move there. All right, now a person weighs 342 newtons on Earth. What is the person's mass? All right, so we say W equals, M equals, G equals. It says the person weighs 342 newtons, and it says on Earth, if we're on Earth, we know the G equals 9.8 meters per second squared. And what is the person's mass? So that would be a question mark. So the question mark always starts our formula, so M equals what? You go and you put your finger over M to give you the formula of weight divided by gravitational pull. Let's fill in our let's fill in our numbers. 342 newtons divided by 9.8 meters per second squared. So when you go to find mass, you're going to type in your calculator 342 divided by 9.8. And that's going to give you a weight of 34.90 kilograms. All right. Now let's go ahead and look at gravity and also Newton's first and second law in our notes. All matter is affected by gravity, okay? And so it doesn't matter which planet you're on even, because as you noticed, at least most of the planets that we've looked at have a gravitational pull. Now, all objects in the universe attract each other through the force of gravity, and that force depends on the strength of that force, depends on their mass, the object's mass, and the distance between the two objects. If the distance between the two objects increases, the effect of gravity is going to decrease, okay? So if I'm on top of a mountain, the force of gravity is less on me than if I'm on the earth or on the ground, okay, as far as not on the mountain. Now, let's talk about free fall. This is when the force of gravity is the only force acting on an object. So when skydivers jump out of a plane, before they open their parachute, they're in free fall because nothing is acting on them except the force of gravity. Now, if you don't have air resistance, now obviously even a person skydiving, unless they're in the pencil form where their feet are the ones pointed to the ground and they're sticking straight up, even if they're laying flat falling, they have a little bit of air resistance. Their body provides a little bit of air resistance. But in the absence of air resistance, all objects falling near Earth's surface are going to accelerate at the same rate because gravitational pull on Earth is always 9.8 meters per second squared. And that doesn't matter of their mass. They're all going to fall at the same rate, okay? And we'll do something in class to demonstrate that. Now, projectile motion. Projectile motion is a curved path that an object follows when thrown, launched, or otherwise projected near the surface of the Earth. Now, if you would like to see this at home, take a ball or take a piece of paper and wad it up and throw it across the room. You're going to see that it has a curved path, and it's because of the gravitational pull. Now, there's two components to the projectile motion. There's a horizontal component, and that's the force that you, like when we're throwing a ball, that's the force your hand provided to the ball so that it can go horizontally. And it also has a vertical force, which is the pull of gravity. When the two motions are combined, they form a curved path. This is also how our satellites stay in orbit. It's from projectile motion. Now, Newton has 3 laws of motion. We're going to learn the first 2 today. Newton's first law, an object at rest will stay at rest unless acted on by an unbalanced force. An object in motion will stay in motion unless acted upon by an unbalanced force. So the easier way to say this is that things keep moving or they continue to stay at rest unless a net force acts upon them. If we have a book on the desk, it's going to stay there. It's not going to move on its own unless I push it off or a gust of wind comes and pushes it off the desk. But it's not going to move unless a force comes and moves it. If something's moving, like if we roll a ball across a room, that ball is going to continue moving unless a force acts upon it. Now, we all know that the ball eventually stops, and the reason is, now, it could hit a wall, okay, and stop that way, which would be a force, but also the force of friction. The ball, it being in contact with the ground, is constantly battling that force of friction, so the force of friction will eventually stop the ball. But anything in motion is going to stay in motion, and anything that's at rest is going to stay at rest unless a force acts upon it. And make sure that you know that that's Newton's first law. Now, we call this inertia, and that's the tendency of an object to resist a change in motion unless an outside force acts on the object. Okay, so this is just Newton's first law. We call it the law of inertia. Force, just the definition of a force, is any action that can change or cause motion. And the net force is the sum of all these forces and has direction. So if I said, let's see, if I had somebody pulling my arms one direction, and then I had a ponytail, and somebody was pulling my ponytail in the other direction. Let's pretend like the person in front of me that was pulling my arms was pulling me at a force of 20 newtons. The person behind me pulling my ponytail was pulling me at a force of 10 newtons. The net force being placed on me would be a difference of 10 newtons, because you would say 20 newtons minus 10 newtons, okay? So that would be the net force. Now, let's look at Newton's second law. The acceleration of an object is proportional to the force acting on it and inversely proportional to its mass. An easier way to say it, force causes acceleration, while mass resists acceleration. So force is something that causes the acceleration, but an object's mass is going to slow that acceleration down. All right, I remember that your notes do have the equation on there, but we'll go ahead and write it and draw the circle. Your equation is force equals mass times acceleration, right? Now, our circle for this, mass and acceleration are next to one another in the formula, so they need to be next to one another in the circle. And then force will have the empty spot. Now, I want you to go ahead and calculate number one and pause the tape. Resume the tape once you're ready for the answer. All right, let's go ahead and start this question. How much force does it take for a 200-kilogram ice skater to accelerate 5 meters per second squared? All right, so it's asked us how much force. So that's going to be a question mark. Our mass is going to be 200 kilograms. And our acceleration is going to be 5 meters per second squared. Force equals mass times acceleration. All right, so let's do this. We're going to fill in our formula with numbers, so 200 kilograms times acceleration 5 meters per second squared. And we calculate that. When you put that in your calculator, you're going to say 200 times 5, and you should get 1,000. So the force equals 1,000 newtons. Now, let's do this second one together because it's a little different. It says a 1,200 kilogram car has a force of 1,500 newtons from the engine pushing it forward. The car also has a combined frictional force of 1,100 newtons pushing it backward. What is the acceleration of the car? Now, we need F, M, and A, right? Now, it says a 1,200 kilogram car. We know that's our mass. Now, it asks us to find the acceleration of the car. So that means it's given us the force. And if you'll notice, there are two forces, one pulling it forward, one pulling it backward. And if you'll remember, for us to find the net force, we just say 1,500 newtons minus 1,100 newtons. So that's going to give us a force of 400 newtons. Now let's go ahead. If we want to find acceleration, A equals, we cover up A on our circle and it gives us our formula. And our formula is going to be force divided by mass. So let's fill that in with numbers. Force is 400 newtons divided by a mass of 1,200 kilograms. And if you put that in your calculators, 400 divided by 1,200 equals 0.33 meters per second squared. Just always remember, acceleration is going to be meters per second squared. Mass will be kilograms or grams. Force is going to be newtons. All right, what I'd like you to do is I'd like you to summarize for today. And I would like you to write a note to an absent student telling them what they missed on the video today. I hope you have a good evening, and I'll see you in class.